Cranky Geek Fall 2022 is brought to you by Google, Spearline, Crisp, and Daily. For more information, see the links in the description.
Hi, Pauli. With us now is Pauli from Daily, and you're going to talk to us about compositing in the cloud with native pipelines and how you scale that up in a large environment.
My name is Pauli. I'm a software engineer at Daily, Daily.co. We're a sort of a full-service web RTC platform. I'm a software engineer working on streaming and rendering solutions. And compositing, of course, means combining images. How this relates to WebRTC is through recording and streaming, very desirable applications. This is actually a pretty hard thing to implement, as some of you may have found out. Some of the fundamental questions here are whose viewpoint to capture and where and when actually do we do the processing, the compositing of the final output. I've got sketched here some participant Alice, Bob, and Cynthia. Next slide, please. And the sort of obvious option would be to capture one participant's view, like in this case we have Alice, and we're just recording client side on her device. Then, of course, in many applications we want a more neutral view, for example, or a customized view that is independent of any of the participants. So we would prefer a server-rendered view. And then another option is to store just the raw track data from each participant and do the composite later as a post-processing operation. Next slide. So how do we choose between these different solutions, client, server, post-processing, immediate, live compositing? Let's consider some of the trade-offs. Next slide. Where really one of the crucial ones is the flexibility of the visual design. We're seeing a lot of demand product side for advanced features. For example, round masks on video, high quality overlays, animations, layout transitions, dynamic text flow so that you can bring in content like social media comments. And the platform would have to at least be extensible to support all of these going forward if it doesn't yet now. Next slide, please. That's a primary concern for a lot of applications, but then of course we've got the usual dimensions like scalability and robustness. Where does the rendering take place? Can it be interrupted by somebody's device going offline? Compatibility, does it produce files that are uploadable to any service or playable on the desktop? Immediacy versus post-processing. Do we get the file immediately or do we have to run something else? And then of course cost. If you're doing it on a client device, it may not cost anything since you're offloading it to a participant, but then servers do have costs. And in general, cloud compositing, we find it's the right solution for most situations, and we've invested quite a lot of effort on Daily to support different cloud compositing scenarios. So some of the essential benefits are that it doesn't burden the user's device. You're not going to be overheating somebody's phone or laptop by having all the rendering on their side. You get a controlled software stack, so it's not going to depend on somebody's browser version or video drivers or all the usual. Of course, the big question always when doing something client-side is bandwidth and the stability of the connection. And especially at Daily, since we're pushing the envelope and supporting up to and over 10,000 active participants on a call, and anybody's feed may want to be called into a recording or stream. So it just makes a lot of sense to do this on the server side where things can be routed within data centers rather than somebody being behind somebody's connection. So since we're looking at the WebRTC application, the sort of obvious solution that comes to mind is, could we just run a full browser instance on the server, capture that live output, and encode it into a video file? Here's a diagram that shows the basic idea. We could run Chromium, capture the GPU buffer, since most these applications do in practice require GPU for the performance that people expect from web applications, and encode that. But there's a lot of buts in this process. And I actually have some personal history here. I was a co-founder at a company called Vidpresso. I think we started around 2012. We built many iterations of a video production tool using a web router engine. We sort of settled on a cloud solution that was using this exact setup I just showed you with a Chromium, a custom C++ front in front of that on AWS GPU instances. It was fully featured. It supported all the design options people expect, HTML, CSS, the whole 9 yards. And eventually we got acquired by Facebook. It was a smallish deal around 2018. And when we tried to scale up this solution, we just found that the scaling obstacles turned out to be pretty unsurmountable. So the problems here is one big is the cost. It was all right at Vidpresso, where we had sort of high-end customers, we had set up the pretty efficient system for multiplexing across GPU servers so that different jobs could run on these expensive machine learning oriented NVIDIA systems that are available from the cloud providers. But really, these are not the right servers for this type of rendering workload. You need a pretty complex stack. There's NVIDIA drivers, X11, Chromium, needs all the stuff to really behave like it does on a client. And it's kind of a headache to maintain on a server. And then it just doesn't scale very well when you're looking at WebRTC processing in this weird context, and it's not easy to profile on the server, and just gets increasingly tough as your WebRTC needs grow more complex. So this is a solution that's pretty hard to push when you're looking at, for example, having 20 people on a call. So the other option would be to go native on the server. Basically, using CPU rendering, you give up on all the GPU goodness. You're not going to be running shaders and CSS blurs and all that stuff that designers take for granted. But it's not a deal breaker, since in most of these applications, we're looking at layouts, masks, overlay graphics, stuff that's very well understood on the CPU rendering side. You can use a familiar OS stack, and there's excellent open source software that has the pieces. You've got FFmpeg, GStreamer. But then the real question becomes, how do we actually let the user define this rendering, assuming we are not just shipping like a handful of predefined templates, which of course is an option. If you know exactly what users need, you might get away with that. But if you need more customizability through an API, then the question becomes, what does that API look like? The sort of most least effort option might be to just expose the media pipeline's native interface, FFmpeg, GStreamer. They have what are basically small scripting languages. You could just script the media pipeline using that, but that creates a very sort of difficult to use and difficult to modify coupling between the user API and what goes on the back end. So the other option might be to roll your own engine on top. You might be looking at sending some JSON that defines layers and scenes, that kind of thing, and thinking, well, this is a pretty powerful thing already. It then translates into the whatever are the native pipeline primitives. But that solution does come with a pretty high learning curve, since then you're asking somebody to learn your new fancy JSON API, all the object types and whatever. And it really does lack the programmability that defines the real engines that people want to use for applications. For the same reason that we have JavaScript running in the browser, this kind of JSON solution doesn't scale very far if you're expected to be constantly sending data updates from an application from a distance. So how about a third option? If we don't have the browser, running the browser itself is difficult, but if we build something that is sort of a browser look-alike, feel-alike, in the sense that it would let you build similar programs and run those on the media server. And we could call this like a simple runtime for real-time video compositing that we could embed in different contexts, maybe not just the server, but also the client side. I've been using the word front-end adjacent to describe the idea that it's not exactly a browser, but it's an easy developer experience if we can use familiar JavaScript APIs, make it feel familiar to people who are coming from a UI engineering background. And then, of course, if we're loading JavaScript code on the server, why wouldn't we make it so that the same rendering code, the same compositing definition could be loaded in a web application as well, and ideally on native mobile too. And some more goals which stem from the media server context. We want it to be as lightweight as possible so that we're not adding a lot of dependencies, and that's a big killer with a Chromium-based solution. And then we also have the option of putting this on mobile and elsewhere. We'd like this to be sandboxed, very tight surface area, API surface area, so that we can actually feel confident about loading these, what are user programs in our cloud pipeline and running them there. So yeah, like I mentioned, I ended up at Facebook after Vidpresso, and there at Facebook, I designed something called React Media, which is not open source. It's an internal project, but it was sort of an experiment of building this kind of engine from scratch, just for video compositing. We did have a browser implementation, but for me, the exciting part was the server-side engine that we called RMRR Rumor, hence the little Fleetwood Mac picture there in the corner. And this was very tightly integrated into the media pipeline that existed at Facebook. It was a custom C++ compositor and using engine that was available internally to create a JavaScript sandbox with bindings. And then now that I'm at Daily, I've sort of taken a second shot at this same concept. We've got something called the Video Component System, VCS, which is React-based as well, runs the familiar React engine, offers a set of components that you can use to define video and graphics and all that stuff. There's an open source core, and then we make it available on Daily's CPAS, as they say, our platform solution, so that any WebRTC call can basically initiate one of these sessions on the server and do streaming, recording, or even multiple sessions at once. And behind the scenes, what happens is that VCS, which is the JavaScript-based engine, it drives the GStreamer media pipeline. We keep all the video always on a YUV color space, while 2D graphics end up on a separate RGBA path, and we only do the absolute necessary color conversions at the end to put these things together. So that's a key factor of how this actually scales to larger calls, and we can have guarantees around even if you mix in lots of graphics and video layers, that things stay on a performance path. So one way to think about it, this whole thing is that this is serverless for live video. Serverless is a pretty popular word, kind of an oxymoron, since of course there is a server, but the whole point is that you don't have to manage the server. You just upload your functions and they run on AWS or Cloudflare or whoever's the provider. So in this case, on Daily's infra, you can do something like this, where you call a start recording, upload your own VCS component code for the stuff you want to display, the layouts you want to use, and so on. And then along the way, you can send update calls to send you data, for example, like, well, let's switch this mode, let's display this data, and so forth. And so a fundamental difference between this and the traditional serverless functions is that they execute very quickly and they go away. But obviously here, since we're looking at live streams, recordings that can last hours, we have to keep that persistent state on the server alive for the whole duration. And that's where a lot of the power of this solution comes from, since we're actually running a live React application that executes independently, but then you can send data along as you go. Next slide, please. And finally, like I mentioned before, sort of a natural outcome of this setup is that, well, what if we take the same compositing code and run it on a web browser client? So in that sense, you can sort of bend the definition here and switch to literally serverless mode, where you've got WebRTC connections, you've got VCS running on a browser, and then you do the compositing on the client. And you're also doing a composite on the server for a live stream or recording or whatever. But this opens the door to customizations, which are pretty interesting for what are nowadays called interactive live streaming products. So you're looking at maybe something where you have guests and hosts and different roles, and you want to show different views. You may have a bunch of viewers who are watching this stream over what is actually a WebRTC connection, and they also can become participants. And this kind of rendering is a pretty strong use case for the VCS approach, because you can use the same compositing code, but then sending commands to customize it for each destination. So let me just go ahead a bit. And this video doesn't have any sound. It's sort of like a showreel type of thing. So really we're looking at here at something that this is a lot of the interactive live streaming experiences tend to end up using these kind of features, transitions, overlay graphics, dynamic components like this little pop-up here, that ideally is not something you have to update from a server. It just could run automatically. And that's what you can do with this persistent React-based approach that we have. Yeah, I think that's all I had. If you have any questions, I'd love to hear them. And then I've got some links. There's a new post just out on Daily's blog, blog.daily.co, if you want to go read that one, which covers a lot of the WebRTC recording solutions and approaches.
Okay. So thank you for that, Pauli. It's been really interesting.
Thank you very much. Thank you so much.
Thank you to our sponsors. Daily. Build communications into any application.